Welcome to this video on trigonometric ratios. Please take a look at the objectives for this lesson. And as we move forward, please pause this video and please complete the following warm-up. Filling out the chart below, make sure your ratios are in simple radical form. We're going to be using this triangle to fill out this column and this triangle to fill out the column on the right. Pause this video to complete this and press play when finished. At this point, you should have filled out the warm-up chart, and we're going to take a look at the solutions now. And so what I already have up here on the screen are the opposite, adjacent, and the hypotenuse sides, obviously based on the fact that A is here. As a quick flash reminder, opposite is going to be the side of the triangle that is not touching the angle that we're talking about. The hypotenuse is always the longest side of the right triangle, and that's going to be this one here, the one across from the right angle. And lastly, the adjacent is the leg that is touching the side we are in question with. So here are our opposite, adjacent, and hypotenuse sides, but the important thing is I wanted to look at the ratio. The opposite divided by the hypotenuse. So when I take that, I'm going to take root 3, and I'm going to divide it by 2 root 3. And when I do that, the root 3's will cancel, leaving me with 1/2. The adjacent divided by hypotenuse is going to give me 3 divided by 2 root 3, which in simple radical form is going to simplify to root 3 over 2. The opposite over the adjacent is going to be root 3 divided by 3, and that simply is going to be my solution. Now, for the triangle on the right, it just so happens, yes, my opposite, adjacent, and hypotenuse sides are all different, but interestingly enough, my opposite over hypotenuse is still 1/2, just like the first triangle we did. The adjacent over hypotenuse ends up being root 3 over 2. Again, I'm taking 8 root 6 here and dividing it by 16 root 2. And then, of course, we are rationalizing that to get our solution. Finally, the opposite over adjacent ends up being root 3 over 3. And so one thing to note here is in our warm-up that the answers to both these questions end up yielding the exact same ratios. And the reason that is that both of these triangles, number 1 and number 2, are both similar triangles. The reason they're similar? Well, these angles that I'm drawing here are right angles, and it just so happens that angle A and angle B are actually both measured 30 degrees. And so another way that we can look at similar triangles is looking at their ratios of 2/3 or 2 of their 3 sides of the right triangle. And that's going to lead us to talk about what's called a trigonometric ratio. Side vocabulary note to note here is that the symbol here, theta, that you will see during this lesson, this can be used as a variable for a missing angle. So if we don't know what the angle is, as we did in our warm-up, instead of calling it A and B like we did here, we actually could use the theta symbol instead, which is what we'll be doing in future problems. So there are 3 ratios that we're talking about. The first one was called opposite over hypotenuse. And in math, we're actually going to give that a special name. The name for that is going to be the sine ratio. And so the sine ratio right here is going to be sine of your angle, which if we don't know it, we call it theta, is equal to the opposite side divided by the hypotenuse side. It's pronounced sine, and abbreviation is SIN. The second ratio is adjacent divided by hypotenuse. We're going to call this one cosine. Cosine of theta is going to be equal to your adjacent side divided by your hypotenuse side. And finally, we have tangent. Tangent is our last ratio, which is going to be our opposite side divided by our adjacent side. And so if we go back to our warm-up, here we have our answers. Instead of calling this opposite over hypotenuse of A, we're now going to call it sine of A and sine of B. Adjacent over hypotenuse, we're now going to call that cosine of A and cosine of B. And lastly, we're going to call this tangent of A and tangent of B. So how do we do this? Well, let's take a look here. Again, we want to label the opposite, adjacent, and hypotenuse side according to the angle. So pause this video and take a look at these 3 problems, and see if you can fill out what's your opposite, adjacent, and hypotenuse. And here is the reveal of those answers so that you can check your solutions to that. So moving on, we're now going to use this vocabulary here to help us find the sine, cosine, and tangent ratios for each angle theta. We're going to do the example here on the left first. And so when I do this, I want to see if I can find sine of theta, which means I'm going to find the opposite side divided by the hypotenuse side. That means in this case the answer is going to be 5 over 13. My cosine is going to be my adjacent side divided by hypotenuse, and so that's going to end up being 12 over 13. And last but not least, my tangent side is opposite divided by adjacent, and we're going to write this as 5 over 12. Remember, if any of these fractions can be simplified, you want to be able to simplify them. Pause this video now and try the two examples on the right-hand side. And here are the solutions on the two problems that you should have practiced here. Notice a couple of side notes here that some of these problems may not have the exact same answer. For example, cosine, you may have written down 24 over 26. However, the answer I have here listed is 12 over 13. Remember that we want to simplify the ratio or simplify the fraction if we are able to. So keep that in mind when doing these problems. For the last example, we're going to take a look at how to find missing side lengths. And so in this problem, we want to find the value of x here, which is actually going to be the opposite side of my right triangle. Notice that we know the hypotenuse side of my triangle is 12. So since I want to find opposite, and since I know hypotenuse, this looks like we want to use the sine ratio. And since we know theta is 50, we're going to write this down as sine of 50, and then we're going to set it equal to its opposite side, which we call x, divided by its hypotenuse side, which here is 12. Now the interesting thing is these ratios, if we know the angles, are actually stored in our calculator. And so if we go to the graphing calculator, we can actually punch in sine by hitting the sine button and typing in 50 for 50 degrees. It's going to give me a ratio here of 0.766. And so we can actually put that in our ratio here and then use this to actually solve for the problem. So to finish solving this problem, what I'm going to do is write in 0.766 for sine, set it equal to x over 12, and then to solve for x, all we have to do is multiply both sides by 12. And so when I do that, all I have to do is take 0.766 and multiply it by 12, and my value of x is going to be 9.192. And so I'll write that down up top here, x equals 9 and we'll just round it to the nearest tenth, so we'll call it 9.2. As your final example in this video, I'd like you to pause it and try the example at the right, trying to find the value of y here, given that theta is 25. Here's a solution to our problem. Tangent of 25 should be what we used. 5 over y is the ratio because it's opposite divided by adjacent. Tangent of 25 is 0.66, so we're going to solve this proportion. I multiplied both sides by y, and then we just divided by the 0.466, giving us a y value of 10.7. This concludes this video. Please go back and rewind and rewatch anything that you may have not understood, and please take a look for further assignments below on Canvas.